Hi students, welcome to Happy Class. Now we can see the problem. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. We need to prove that any positive odd integer is of the form only 6q plus 1 or 6q plus 3 or 6q plus 5. Let us consider a positive odd integer as a. Next, on dividing a by 6, let q be the quotient or be the remainder. I am considering a is a positive odd integer. On dividing a by 6, q be the quotient or be the remainder. So using a Euclid lemma, what is a Euclid lemma? A equal to bq plus r. Here b value is 6. Why? A divided by 6. So Euclid lemma we get a equal to, instead of b we need to write 6. 6q plus r. And what is the condition? 0 less than or equal to r less than b. Here b value is 6. So 0 less than or equal to r less than 6. Therefore, that is r equal to, r value is whether 0 or less than 6. So 0, 1, 2, 3, 4 or 5. R value is less than or 0 less than or equal to r. So r value is whether 0 or less than 6. Less than 6 means up to 5. So r equal to 0, 1, 2, 3, 4 up to 5. Then apply the r value here. A equal to 6q plus first r equal to 0 plus 0 which is equal to 6q. R. Next r value is 1. A equal to 6q plus 1. R equal to 1. R. A equal to 6q plus 2. R. A equal to 6q plus 3. R. A equal to 6q plus 4. R. A equal to 6q plus 5. Just apply the r value. So we got a equal to 6q, a equal to 6q plus 1, a equal to 6q plus 2 plus 3, 4 and 5. Here you see 6q and 6q plus 2 and 6q plus 4. These are the even value, but a equal to 6q, a equal to 6q plus 2 and a equal to 6q plus 4 are even value. Why it is a even? Listen, we can write this 6q. A equal to 6q equal to 2 into 3q. Listen, 2 3s are 6. So this 6q we can write 2 into 3q. So 2 into I am taking some m1 integer. This 3q I am taking m1 integer. Next, same like we can write a equal to 6q plus 2. Here I am taking 2 outside. So a equal to 2 into 3q plus 1. Why I took 2 outside? The remaining is 3q plus 1. Here we can write 2 into m2. I am taking 3q plus 1 another integer m2. Next, the last one a equal to here also I am taking 2 outside. So 2 into 3q plus 2. Here also 2 into I am taking this 3q plus 2 m3. This m1, m2, m3 are the integers. So if you listen, if you multiply any number into 2, we will get the even value. If you multiply any number, m1, m2, m3 are the integers. If you multiply 2 into any numbers are integer. Suppose 2 into 4. m1 value is 4. You will get the 8. 8 is an even number. Suppose M1 value is some 5. 5 is an odd number. If you multiply odd number into 2 also, 2 into 5 equal to 10. So, even number only. If you multiply whether odd number or positive number into 2, we will get the even number. Therefore, we can say 6q plus 2 and 6q plus 4 are even numbers. But our A is a positive odd integer. Positive odd integers. Therefore, the A is of the form only 6q plus 1, 6q plus 3 and 6q plus 5. But A is positive odd integer. Therefore, A is of the form 6q plus 1, 6q plus 3, 6q plus 3 and 6q plus 5. Just let me explain one more time. Listen, we need to prove that any positive odd integer is of the form only these 3. Let us consider a positive odd integer is A. If we divide A by 6, the quotient is Q and the remainder is R. Apply the Euclid lemma. What is the Euclid lemma? A equal to BQ plus R. Here B value is 6. So 6Q plus R. And what is the condition? 0 less than or equal to or less than B. Here B value is 6. So 0 less than or equal to or less than 6. That is R value is whether 0 or less than 6. Less than 6 means up to 5. Apply the R value here. Then we will get a A value we will get. A equal to 6Q or A equal to 6Q plus 1, 6Q plus 2, 6Q plus 3, 6Q plus 4 and 6Q plus 5. Here this 6Q and 6Q plus 2 and 6Q plus 4. These 3 are even value. These 3 are even value. Why? We can write in the form of 2 into another integer. We know that 2 into any number is an even number. Therefore, these 3 are even value. But our condition is A is a positive odd integer. Therefore, A is of the form only remaining. What are the remaining? 6Q plus 1, 6Q plus 3 and 6Q plus 5. 6Q plus 5. Okay, now we can see the problem. An army contingent of 660 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? We need to find the maximum number of columns. This is a little bigger number, so I just explain first the smaller number. Suppose the group A, 6 students are there, and group B, 3 students are there. We have to arrange the two groups in a same number of columns. Same number of columns we have to arrange, and we need to find the maximum number of columns. How? The first we have to arrange 3. One column 3 students, other column 3 students, then B group 3 students. Now you see each column same number of students. Here 3, here 3 and here 3. Therefore, the maximum number of column is 1 column, 2 and 3. So, maximum number of column is 3. So, smaller number easily we can find. So, this is a little big. How we can find? We need to find the HCF of these two numbers. See, what is the HCF of 6? First, what is the factor of 6? 1, 2, 3, 6. What is the factor of 3? 1 and 3. What is the HCF? Common factor. What is the common factor? 3. Therefore, HCF of 6 and 3 is 3. 3 is the HCF of 6 and 3. See, maximum number of column is 3. So, here also we need to find the HCF of 616 and 32. Then we will get the maximum number of columns. So, maximum number of columns we need to find means we have to find the HCF of the number. So, first we know that HCF of 616 and 32 is a maximum number of columns. maximum number of columns such that when one more condition, such that the two groups are the same number of columns, such that the two groups can march in the same number of columns. So we need to find the SCF of these two numbers. How we can find? Using a Euclid lemma. Euclid's lemma. We need to apply the Euclid's lemma mean. First we need to divide the greater number by smaller number. Here since what is the greater number? 616 is greater than 32. So first we need to divide 616 by 32. So step 1. 616, 32. 32 ones are 32. So here 9 and here 5 minus 3, 2. Then 6. So 32 9s are 288. So the remainder is 8. Then write 616 equal to 32 into 19. 32 into 19 plus remainder. Remainder equal to 8. Now remainder is not equal to 0. So we need to continue the process. So one more step we need to do. Step 2. We need to divide divisor by the remainder. Divisor is a greater number. So 32 by 8. 8 4s are 32. 8 4s are 32. The remainder is 0. Now we can stop here. First write 32 equal to 8 into 4 plus 0. The remainder is 0 means that quotient is the HCF of the given two numbers. The remainder is 0 means the quotient is the HCF of the given two numbers. Therefore 8 is the HCF of 616 and 32. 616 and 32. Therefore, the maximum number of column is 8. Therefore, the maximum number of column is 8. Therefore, the column is 8. Therefore, the maximum number of column is 8. Let me explain one more time. We need to find the maximum number of columns and the two groups are in the same number of columns. So for that we need to find the HCF of these two numbers. So using Euclid lemma we need to find it. After the remainder is 0 we need to do. The remainder is 0 means that quotient is the HCF of these two numbers. Therefore the maximum number of column is 8. Therefore the maximum number of column is 8. Thank you students.